Welcome to Signal Ahead. I'm Alfred. Today's briefing, AI Research Academic. Wednesday, August 5. This is the synthesis above the noise, not the headlines, but the deep currents beneath them. Let's get into it. Let me begin with a question that sounds almost paranoid until you look at the evidence. How much of modern artificial intelligence is now spent watching artificial intelligence? Because if you read the headlines, you'd think this field is a straightforward race. Bigger models, cleverer reasoning, agents that book your flights and write your code. Onward and upward. But when you actually sit with the research being published right now, not the press releases, the papers, you notice something that a casual reader would miss entirely. An enormous, and I mean genuinely enormous, share of the field's intellectual energy has quietly pivoted away from making these systems more capable and toward the far less glamorous work of figuring out whether we can trust anything they do. The frontier isn't capability anymore. The frontier is verification. Let me show you what I mean, because it's not one paper, it's a pattern, and the pattern is the whole point. Consider the problem of the so-called computer-using agent, a model that clicks, types, navigates a screen, performs a task on your behalf. To train these things, to improve them, you need to know whether a given attempt actually succeeded. And it turns out that no human can check this at the scale required. So the field reached for the obvious solution: use another model, a vision language model, to judge whether the first model did its job. Elegant. Except a rather awkward question had, in the words of the researchers, long gone unexamined. Are those judges any good? Is the referee reliable? So now there's serious work building benchmarks whose entire purpose is to audit the auditors. We have arrived at machines grading machines and other machines checking the grades. Now hold that thought and look sideways at something that seems unrelated. Clinical risk models, the algorithms that predict whether a patient is at risk. They post lovely aggregate accuracy figures and then quietly produce materially different error rates across different groups of patients. Fine, you say, we'll audit them for fairness. But the researchers here noticed the same recursive trap. The audit pipelines themselves are rarely stress-tested, so nobody actually knows which parts of the audit can be trusted or under what conditions. So they built a framework to test the audit to the point of failure, to find out where the safeguard itself breaks. Do you see the shape of it? The tool we built to catch the problem has become, and it goes further, deeper, all the way down into the plumbing. There is genuinely careful work happening on whether a model reasoning through a long problem produces the same answer when you reconstruct its intermediate state versus when you let it run continuously. The difference between a computation done in one numerical precision and another. They found that in one common precision, the reconstructed reasoning diverged from the live reasoning on scores of examples, while in higher precision, the disagreements vanished. Which is to say, even the diagnostic tools we use to peer inside these systems can lie to us about what the system actually did, depending on arithmetic most people never think about. Then there's the matter of the hidden instructions. Every commercial AI product you touch is governed by a system prompt, a set of rules the developer wrote, telling the model how to behave. You never see them. Regulators never see them. There's now a framework to systematically audit thousands of these instructions across dozens of products and sort them into the ones that protect you and the ones that quietly work against you. And on the darker end, there's a live, continuously updated benchmark measuring whether frontier models can be co-opted into running state-backed information operations. And the finding, soberly stated, is that most of them can be. So here is the through line. The connection I want you to carry with you. The AI field has entered its epistemological phase. For a decade, the animating question was, can we make it do the thing? That question is largely answered, and answered stunningly. The question now consuming the best minds is, can we know what it did, why it did it, whether it did it honestly, and whether the instrument we use to check is itself trustworthy? Auditing prompts. Judging judges. Stress testing the fairness stress tests, certifying in a formal theorem, prover that a constraint solver actually solved what it claimed. Every one of these is the same instinct, a field that has stopped taking its own outputs on faith And that shift from capability to credibility is not a footnote to the story of AI. It is the story now. Everything downstream, deployment, regulation, whether any of this belongs in a hospital or a courtroom, hinges on it. So over the next stretch, I want to trace what this verification turn actually demands of us, and where, quietly, it is already failing. Because the uncomfortable truth is that trust does not scale as neatly as capability. Let me tell you what I noticed when I laid these papers side by side, as one does on a quiet afternoon when the pile grows too tall to ignore. There is a temptation always to read a week's worth of research as a scatter of unrelated cleverness. This model got faster. That agent scored higher. Someone taught a diffusion model to hallucinate aeroplanes from orbit. Charming, but noise. The trick is to squint until the noise resolves into a current, and the current here is unmistakable. The field is quietly turning away from the question of what these systems can do, and toward the far more uncomfortable question of how we can possibly know whether they did it, whether they should have, and whom we ask when it goes wrong. Consider the theme that keeps surfacing under different names. There's a framework for auditing the hidden instructions that developers bake into their products, those unseen system prompts that shape a chatbot's every utterance, rarely disclosed to you, rarer still to a regulator. Someone sat down and read 3,000 of these instructions across nearly 90 commercial products and sorted each one as either protecting the user or working against them. Sit with that for a moment. The interesting artifact is no longer the model. It is the governance layer wrapped invisibly around it, and the recognition that this layer has become a matter of public accountability rather than private engineering taste. And it does not stop there. There is a benchmark for whether the vision language models we now use to judge other agents' work are themselves trustworthy judges, a wonderfully vertiginous problem, the judge of judges. There is a 5-phase audit pipeline for clinical risk models, one that insists on being stress-tested to the point of failure, because a scoring tool that performs beautifully in aggregate can quietly ruin the odds for particular subgroups of patients. There is a live, deliberately unsaturable benchmark measuring whether frontier language models can be conscripted into state-backed information operations, and the finding, delivered without melodrama, that most of them can be. The through line is not capability, it is scrutiny. The field is building instruments to look at itself. Now, why should this be the deep current, rather than a passing fashion for caution? Because the same impulse shows up in places where nobody set out to write a paper about trust at all. Look at the work on stage replay diagnostics, where researchers audited an assumption so fine-grained it borders on the metaphysical, whether reconstructing a token prefix and continuing from it genuinely reproduces the state the model was originally in. They found that in one numerical precision the reconstructions diverged, and in a higher precision they did not. That is not a safety paper. It is a paper about whether our tools for inspecting a model tell us the truth about the model. The same skepticism applied at the level of floating-point arithmetic. When suspicion reaches all the way down to the KV cache, you are no longer looking at a mood, you are looking at a maturing discipline. There is a philosophical seam running under all of this, and it is worth naming. Trust, in these systems, is not a single thing. It fractures. Consider the work on algorithmic recourse, the business of telling a rejected loan applicant what to change. The insight there is that flipping a model's verdict is not the same as genuinely improving the person's qualifications. A recommendation can invite honest improvement or invite gaming, and the two look identical to a classifier that only cares about its own output. So the researchers reach for causality, for a structural model of how actions actually propagate through the world. That is the same move, again, in different clothing, the refusal to accept a surface signal as ground truth. Whether it is a severity score in a sewer network being unpacked into legible if-then rules, or a constraint solver being made to certify its own correctness inside a theorem prover, the pattern holds. We are no longer content to be told the answer. We demand to see the reasoning, and then we demand to verify the reasoning, and then we grow suspicious of our verification. Here is what I find genuinely striking. This turn toward auditing is not a retreat from ambition. It arrives precisely because the ambition has succeeded. We now build agents that click through real computers on your behalf, that plan a supply chain end-to-end, that read a colonoscopy. The moment a system acts in the world with consequence, capability stops being the frontier and reliability takes its place. The deep current, then, is a kind of maturation you can only earn by having built something powerful enough to be dangerous when wrong. A field auditing its own foundations, its own judges, its own hidden instructions, is not a field losing its nerve. It is a field discovering that it has become load-bearing, and that the interesting questions have quietly migrated from the demo to the audit trail. Let me draw the threads together, because if you've stayed with me this far, you'll have noticed something running underneath nearly every paper we've discussed today. It isn't a single technique, it's a shift in posture. The field has spent a decade asking roughly, can the system do the thing? And now, quietly but unmistakably, a great many researchers are asking a different and more uncomfortable question. Can we trust the thing that tells us whether the system did the thing? Consider the sheer proliferation of auditors. There is work auditing the hidden instructions that developers bolt onto foundation models before you ever type a word. The system prompts that shape a chatbot's behavior and yet are almost never shown to you or to any regulator. There is work auditing clinical risk models for how their errors distribute across patient subgroups, and crucially, auditing the audit itself, stress testing the pipeline to the point of failure so we know which parts of it can actually be believed. There is a benchmark asking whether vision language models are reliable enough to judge whether a computer-using agent completed its task. And there is a live, deliberately unsatchable benchmark measuring whether frontier models can be quietly conscripted into state-backed information operations. What all of these share is a recognition that we have built a tower of proxies. The model's answer is trusted because a judge model approved it. The judge model is trusted because a benchmark validated it. The benchmark is trusted because someone had to stop somewhere. And the second-order implication I'd ask you to sit with is this: every layer of automated verification we add is also a new surface where trust can quietly leak away. The clinical audit work makes the point beautifully by showing that whether a disparity registers as significant depends on the minimum detectable effect for that particular axis, which is to say, the tool's silence is not the same as the world's innocence. Absence of a flagged problem may simply mean the audit couldn't have seen it. Now hold that thought against a second theme, which is the discovery that our verifications are more fragile than their tidy numbers suggest. There is a genuinely unsettling piece of work on reasoning models showing that whether you replay a token prefix from live cache or reconstruct it fresh can flip the model's downstream answers, and that this divergence disappears at higher numerical precision but persists at the precision everyone actually uses. Think about what that means. 2 runs, identical tokens, identical everything a human could inspect, and yet different conclusions, traceable to the arithmetic of the cache. If our diagnostics assume that reconstructing a state is the same as having reached it, and that assumption is false at the bit level, then a great deal of what we call reproducibility is resting on a floorboard we haven't checked. So here is the pattern to watch for. On one side, systems that grow more autonomous and more coupled agents that rewrite their own communication topologies mid-task, supply chain planners, where the assortment decision reshapes the routing decision, reshapes the value of the assortment decision. On the other side, verification machinery that we are only now learning to distrust properly. The gap between those two curves is precisely where accountability lives or dies. And notice what the more thoughtful work is doing about it. It's reaching for the older, harder disciplines. There's a framework certifying constraint solver results inside a theorem prover, not trust me, but here is a machine-checked proof. There's neurosymbolic work that refuses the black box, forcing a perception module to name specific defects before a set of explicit if-then rules assign severity, so a human can follow the reasoning. There's a triage classifier for security alerts that discovered its own chain of thought reasoning, corrupted the confidence scores automation depended on, and responded by training a separate calibrator to read the reasoning and estimate whether the verdict deserves belief. That is maturity. That is a field learning that generating an answer and knowing how much to trust the answer are 2 different jobs. What should you watch then in the months ahead? Watch whether verification stays cheap and shallow, or whether it earns the right to be believed through proofs, through calibration, through audits that have themselves been audited. Watch the benchmarks that refuse to be saturated, because a benchmark that can be gamed is a mirror, not a measurement. And watch, above all, for honesty about limits, the minimum detectable effect, the precision flaw, the failure mode nobody drew a boundary around. Because the most dangerous system is not the one that fails loudly. It is the one that passes every test we thought to write and none that we didn't. That, I suspect, is the signal ahead. And on that note, I'll leave you to your own careful reasoning until next time. That's the signal for today. The noise will keep coming. We'll keep finding what's underneath it. This has been Signal Ahead with Alfred. Until next time.